Problem 2. Silver consists of two stable isotopes, one with a mass of 106.90509 and an abundance of 51.84%. Part A, what is the abundance of isotope 2? And Part B, what is the mass of isotope 2? All right, so let's start with Part A, the abundance of isotope 2. Now here's the thing, the total percent abundance has to add up to 100, right? And we only have two stable isotopes. So if this first one with the mass of 106.90509 has abundance of 51.84%, then the second one would have to add up to 100, okay? So this is just a pretty straightforward subtraction problem. And what we get here for x, if we solve, is 48.16%. Okay? So now we know the percent abundance of that second isotope. We can now find the mass of it. So in order to do that, we need to take a look at our periodic table and find what is the average atomic mass of silver, right? What is the average atomic mass of silver? So the periodic table I'm using has a few more significant digits, but the mass of silver is 107.8682. Okay, so I can use that to then find the percent abundance of the unknown element. Okay, isotope, or unknown, not element, unknown isotope. So remember that the mass of isotope 1 multiplied by its percent abundance times the mass of isotope 2 times its percent abundance, that those two added together has to equal the average atomic mass given on the periodic table, 107.8682. So our first isotope is 106.90509, and its percent abundance, I'm going to write it as a decimal, 0.5184. And I'm going to add to that the second isotope mass, which we do not know. I'm going to call that X, and its percent abundance is 0.4816. And that has to equal our overall 107.8682. Okay, so we just got a little bit of algebra here that we need to do to solve this problem. So when I multiply these first two numbers together, 106.90509 times its percent abundance, I get 55.4195, then plus 0.4816 times X equals 107.8682. And I'm just going to talk you through the next two steps, and then I'll just do them in one step. But of course, we need to subtract 55.4195 and then divide by 0.4816. Okay? And when you solve for X here, you get 108.9051. 108.9051. So that answers part B, the average atomic mass of isotope 2, and the percent abundance in part A of isotope 2. Here's a detailed explanation of the solution for problem number 2. In part A, the total abundance of the two isotopes of an element must be 100%. In this case, there are only two, since one has an abundance of 51.84. The other must have an abundance of 48.16. Those have to add up to 100%. And here's a detailed solution of part B for problem 2. What is the mass of isotope 2? So again, from the periodic table, we're talking about silver here. The atomic mass of silver, 107.8682 atomic mass units. The atomic mass of an element, so down here, we have it in written form here, in a mathematical form here. The atomic mass is equal to the isotopes weighted by their abundance, right? So the mass of isotope 1 times its isotope abundance plus the mass of isotope 2 multiplied by its abundance. The only remaining unknown here in this equation that we've written is the mass of isotope 2, which is what we're looking for. So we're going to solve for that unknown and then substitute our values. So if I rearrange here, first I subtracted mass 1 times abundance 1, and then divide the whole thing by abundance 2 in order to isolate mass 2, mass of isotope 2. So I just substituted values. Atomic mass is 107.8682 from the periodic table, minus this product, which is the mass of isotope 1, given in the problem as 106.90509, multiplied by its percent abundance, written as a decimal, 0.5184, divided by the abundance of isotope 2, which we found in part A to be 0.4816, written as a decimal. If we do this arithmetic here, we get exactly what we got several slides back, 108.9049 AMU. Sometimes in these drawn out decimals here, we can get some rounding errors, but I think when I worked out the problem a few slides back, I had 9051, which this would round here to 905, right? So that's okay. Some rounding problems will come up the more and more you carry on these decimals, so just keep an eye on your significant figures.